Next week, I will be gone. So I'm giving you a heads up right now. What's going to happen is you will end up, and I'll go over this again on Thursday. I'm trying to get it in your heads once so it's fresh when you come next week. Next week is a lot easier week than this week. This week's a hard week with quantifiers and quantified statements. I would say this is like the last of your super hard stuff. Next week it gets a little easier again. Hey, go ahead, Simon says. Next week it gets a little easier again. Getting back into, we're not back into, but we're going to get into some sets and subsets, and we're going to talk about how different groups of objects intersect in union. So that I will have videos for you next week that will be in Canvas. Okay. Emily and Allie will project them up on the board. Okay, and you guys will do you'll watch the video, and then you'll work on your assignments in class once the video is done. It'll be pretty simple. Okay. Week after that, we have our post-test and our last exam. So the third test, there's a post-test, and then there's exam 3. Exam 3 will cover week 6 basically. Okay, all the week 6 stuff will be in exam 3. And then the post-test will cover everything from the whole semester. Okay, you'll have 2 post-tests. You have a mini post-test and a longer post-test. So that's your next 3 weeks.
How long was the post-test?
Like 20 questions. I don't know. I'd have to look at
The
it.
big one?
I don't know. I'd have to look at it. I don't have memorized it. So, give me a second. Okay, here's the other thing. I got some of your guys' exam 1 corrections back. I don't like them because some of you just gave me like things like they weren't explanations. So let me give you an example of how this looks. I'm going to give these back to Emily and Allie. So those of you that did the corrections, I need you to go look at them again because they're not what we need. Okay? I could care less about the right answer. I really could care less that, oh yeah, you found the right answer, great. But tell me why the right answer is right. So for example, let me look at this one. So if I miss number 1 on the exam, let's say number 1, you got to fill in a definition. Let's say you missed a definition question. Okay? And the definition was, for this case, the blank, if P then Q reads as if P then Q, is a statement that is false if and only if P is true and Q is false. P is the blank and Q is the blank. So, when you go to get the right answer, give me the right answer and explain, well, I think, P is called if we have an if P then Q, what's P called?
Antecedent.
Antecedent. It's called the antecedent because it comes first. Antecedent comes first. And what's the Q called? Consequent. The consequent is the second value in a conditional statement. That's the explanation I want. Okay? Don't just give me the answer and say this is what I decided it was. Okay, and on a true-false question. If you answered true on a true-false question, what's the real answer?
False.
Right. But why is it false? Okay? I want to know why the answer is false. So let me find one of those real quick. Let's see. I think we had. I guess we can count one of those. Oh yeah, we had a truth table. So on the truth table, you would say, if I had a false true, you don't just switch it and say, well, that's what it is. Well, you got to explain, well, it's because my first statement, let's think about this. Let's see. If I have a conditional statement, let's say this is your truth table. Okay? And I have P, Q, if P, then Q. Okay? Anyone see that okay?
Yep.
Okay? So, if I'm going to fill out this little truth table, which your guys' truth tables are now bigger. So if I fill this out, I know that this could be true, true, so true, 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 false, false, true, false, false. Yes? True, true is?
True.
True, false is?
False. True. 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 True.
Okay, so if this was the error, okay, you find that, hey, that's the error in your truth table. Okay? Oh, Mr. Robinson, I noticed that when I have a false true conditional statement, it really needs to be true and not false. Because the only time in a conditional statement that our conditional statement is false is when we have a true false. Okay, so I need an explanation. Not just, yeah, it's true instead of false. Make sense? So let me just read some of these real quick. Let me see if I can find any other ones I didn't like. Maybe some of those are okay.
Bless you. Bless you, Emily.
I am vaccinated. Ooh.
I am sure you are.
And then on some of these, hey, some of you that did the corrections, you didn't correct all of your problems. I want all of the ones you missed need to be on the correction. Some of you did like 4 of them and said, oh, I'm just going to fix this one question because it's worth the most points. No, that's not how it works. You go fix them all. Okay? That is the other thing. Yes?
Mr. Robinson,
Yes?
are we going to do exercise 19 or exercise 18 today?
Yes?
Or,
Both. Okay. So, any questions about how to do corrections? Okay, so I'm going to give these back to Emily and Allie. They're going to give, those of you that didn't get a 70, you're going to look at them again and make sure, 1, you answered all of the questions, all the corrections. Okay? 2, make sure you give me some good explanations. So I need a mathematical explanation. Like this. The only time the conditional statement is false is when we have a true false. That would be an explanation that I want. I can't do that for every question right now, but that's the kind of explanation we're looking for. Emily and Allie, does that make sense? When you guys look at them? No?
Say that all again.
So when they do the corrections and give an explanation, it needs to be a mathematical explanation of why it's right. Does that make sense? Or why the answer was wrong. Okay. Is that okay? Alright. So don't know what to look for. Don't give me I don't know and I didn't study. It's obvious you didn't study. I can pick that out. Okay? So those of you that are there, make sure you get that done, please. So I'll give these back to them. All you have to do is give me the corrections and I give you a 70%. You don't have to retake anything. I just need a better effort on the corrections. You guys good? Okay. I saw that one. I bought the other one for $2.99.
That's pretty good. That's pretty
On
good.
Kindle. That's on sale.
How excited these got. Oh my
They're
goodness.
so good.
Okay. Okay, I also have your guys' quiz 3s. So these I'll give back to Emily and Allie. If you scored below a what?
70%.
You have to do corrections. Okay? What this does, you guys, if you guys do the corrections, you get a 70%. If you have a 70% on every quiz and every test, you pass prep, right? And on your assignments. You gotta have 70% on your assignments. So, the quiz I was actually pretty pleased with how you guys did. It was pretty good. Some of you just go back and fix what you didn't do well on. On the quiz, actually, I'm just going to hand these back right now real quick, and we'll look at them. Yes?
So, just wondering, does it matter if we don't pass prep?
Huh?
Does it matter if we don't pass prep?
You don't get your credit, and I don't think you get to come back. It's a 3-year program, right? So you guys got to pass each year. That's something to ask Mrs. Martin, I guess. That's the way I understand it. Actually, we're not going over quiz 3. I got some people that need to finish it still.
Can we just go back and look at them, but not
No.
look at them?
So I can't have you give it back and look at them when I got some people who haven't finished it. I can't talk about it. Does that make sense? So, quiz 3, real quick. I will give Emily and Allie the answer key. Okay? They can break down the points where you missed. Each page, each question, the first page is worth 10 points. The second page is worth 18, and the last page is worth 9. Okay? So the page with the truth table, that was worth the most, because there's lots of work there, right? So you guys can look at those. When you guys did them studying hall today, if you got below 70, go ahead and look at them. Like I said, I can't. Actually, we'll go over these tomorrow. Let's do that. We'll do that, because then I can let those that need to finish today. Let's do that. Let's do that. Okay. Any other questions regarding what's happening or corrections? Yes? We're going to. Okay, heads down. Let's see how many of you listen. How many people understand how to do their corrections? Raise your hand if you understand how to do your corrections. What you need to do. Raise your hand if you kind of understand. Raise your hand if you don't understand. Hey, heads up. Okay. If you don't understand what to do with the corrections, you need to ask. Okay, don't do half-baked jobs. All right. Compound quantifiers and quantified statements. That's what we're at. So you guys, I don't know what page it is. We'll look here in just a second. 51?
Are we supposed to do exercise 18?
Yeah. Okay, exercise 18 is where we left off last time. We're going to go through it because it's a little more difficult. So go to exercise 18, so page 50. Yes, you're supposed to get started on it or finish it. I can't remember where we were at exactly.
Yeah, you said just read how it's
Read through it? I can't remember what I said. It's been a long weekend. Read through it sounds good. Okay, we're going to walk through it though. So everyone go to 18. We're going to start with this one. I need a reader. Go.
Given the statement, all Republicans are conservative, find its negations in policy, and then translate the negation in standard form.
Find its negation symbolically and translate in standard form. Okay, what's symbolically versus standard form? What's symbolically versus standard form? Yes?
And symbolically, you just put it not. And in standard form, you actually write it out.
Yeah, standard form we're going to write out with words, right? Symbolically, you're just going to use symbols. Okay? So I want you guys to go ahead and try. I'm going to give you guys 1 minute. Find the negation symbolically. All Republicans are conservative. Find the negation symbolically. All Republicans are conservative. You got a minute. Ready, go. You need to try. Try is all I'm asking. Just try. So when it says find it symbolically, you got to think, okay, what did we do in class last week? We're going back quite a few days. What does that mean? Well, look back in your notes a little bit and see what that meant. And then if you could translate the negation, I mean putting it into words, please do that as well. You're finding the negation symbolically and then putting it into words. How you would say
saying
it,
it out
yes.
loud, or does it mean like writing down? Like, what do you mean like writing down for every X there's?
Both. You can do either way. Because you could say it that way, right? It still means the same thing as writing it that way. So as long as you follow one of the ways to write it, you're good. Okay, who's got the symbol for me? You want to try? Go for it.
Not EX and R.
Not EX. What do you mean? Like an E?
That is EX. Well, no, not EX.
Isn't it a backwards E?
Like not, I put the not in it. It's just E, X,
Backwards E or E?
backwards E.
Okay, forever. There exists, right?
Yeah.
Okay.
Then if RX, then CX.
What does the RX mean?
Republicans are.
Okay. Is a Republican, or are you right? The X's are term. Yes?
And
Okay.
then are conservative.
Are conservative. So what do I need to write next? What symbol?
Conditional. Because we're doing everything.
Conditional symbol. Okay. What else? Or is that it?
That's it.
Hey, does anyone else have anything to add to it? What do you got?
Mr. Robinson.
So you think we have our for every there?
Yeah.
Instead of the, okay? It's all right, we're looking at arguments here. Violet, what do you think?
I think it should be the top one, only with the not before the C.
Okay, so Violet says, hey, look at this. What do you got?
I think it's some at some not RX and then and not CX.
Yeah.
Like that?
Yep.
Okay. What do you think next?
And also I want to negation for the EX and the AX.
So you like a negation here like that?
No, outside purposes.
So you would say like this. Like that?
Yeah.
Okay. Let's look at some things. Yes.
So what Max said, wouldn't that be logically equivalent to what I said?
Let's look at all three.
Actually, no, it would be logically equivalent to the one above that one because when you do a conditional statement, then it goes into
So Max, you're thinking the negation of the whole thing, right? Okay. Here we've got negations happening. We've got a negation of for every, because the negation of for every is there exists, yes?
Yes.
So, looking back at our notes, let me just pull those up real quick. Let's go to this page here. Let's see. Negation of so if we have one like this, so we have P, okay, was for every X there exists a tiger. If X is a tiger, then X is a cat. You guys see that right there at the top of my page? See that? Okay. We said to negate this statement, which is very similar to what we're starting with on ours. Our statement is for every X, if X is a Republican, then X is a conservative, is what their statement really is. It says all Republicans are conservatives, right? Which is another way of saying this. So if we take this statement and compare it with this one here, oh yeah, we know this is what's going to work. We just switch out the letters. But those are equivalent statements. If we're taking a conditional statement and we're just going to negate it with our quantifiers, If we negate the quantifiers, negate the statement, this is what we get. Because W and P here are, W is the negation of P in this example. So this is one example you can go look at. If we take Max's, he says, look, I want to negate the whole thing. And just put the negation out in front, right? And that's also logically equivalent to our other statements. So these statements are used over and over again, even though, remember, they're different words, the statements are used over and over again. Okay? I need you guys to pay attention to your moves. Split up. Okay? B, hey. Seriously. Okay? Well, you guys have been doing something the last 5 minutes. I need you to pay attention, please. Okay? So, yes, the official statement we want is going to be this one we would have to rewrite it like this. Okay? We have to put some brackets there.
Is it okay if I kind of did that same thing, but instead of putting the brackets, I also put a negation in front of the parentheses of the R and C?
If you start simplifying this correctly, then you can still get points for it. So here's how I would break this down. I would say, well, look, this is like 100%, right? This is like what we want, is this guy. Okay? This would be like, okay, that's like a 70%. You know what you're talking about. Okay? Does that make sense? So these are both okay. If you start to simplify this, and you simplify it correctly to another equivalent statement, I'm okay with that too. Okay, so as long as the statements are equivalent, you're showing a negation of our original statement. Those are what we want. Okay, so symbolically, that's what it looks like. Now, translating the negation. Okay, there exists an X. Actually, I'm just going to show you the options they have because there's 4 different options, and I don't want to write them all down because it'll take too much time, more than we have. So there's 4 different options for part B here. Here are the options. Okay, here are your options for part B. So the first one, there exists an X such that X is a Republican and X is not a conservative. There exists a Republican X and X is not conservative. Some Republicans are not conservative, or not all Republicans are conservative. Okay, these are ways to write the negation. There's 5 different ways. Okay, we have 5 different statements that we talked about earlier in our notes. If you go back and look at those 5 different ways to write a negation of a quantified statement, it tells you, hey, look, here are the 5 ways you can do a negation of a quantified statement. Here are the 5 ways you can write your quantified statement. Yes?
Would this work? There exists an X if X is a Republican, X is conservative? Or X is not conservative?
That would be very similar to this one. Like, take out the if. Because we're not saying if X is a Republican, we're saying X is a Republican and X is not conservative. Yes?
So which one of these would you just use?
All of them's fine. You can use any one of them when they're right.
They're like all full credit at all.
Yep, those are all full credit. Okay, the symbols, the reason those would be kind of partial credit is we want to get down to this symbol because this is like the most simple symbolic form. Or simplified symbolic form, I guess we could say. Other questions there? Okay, let's look at number 2. You guys have a minute. Ready, go. Do number 2. Do number 2. Some Democrats are not politicians. You need to write the negation symbolically. So what you must do on the first part, think about how you would write the original. Some Democrats are not politicians. How would I write some Democrats are not politicians? How would I write that? Yes?
No Democrats are not politicians.
No. How do I write this? Some Democrats are not politicians. How do I write it symbolically? How do I write it symbolically, Violet?
So the backward E and X and what inside parentheses, and then a D, X, and a conjunction with not P, X.
Good, that would be good. There exists an X, okay, where X is a Democrat and X is not a politician. So you want to write the negation for this statement. Go ahead and write the negation. Symbolically. Right, this negation symbolically. Yes?
Sorry.
Would it be, the upside down AX in parentheses?
Okay?
And then, DX if, or, then, P, not PX.
Okay, any others? Yes?
I'm pretty sure you shouldn't have that not, because because in the statement that we're finding the negation of, it says some Democrats are not politicians, so we would want them to be.
Okay? What do we think? Do you agree with her?
Yeah. Yeah.
So we gotta switch this one so it's just PX?
Oh,
Is that good? 'Cause that way it switches the value. We wanna switch this value. Okay, we switched our quantified statement, our quantifier. Okay, yes?
So, either one would work?
No, this is the original statement, this is the negation. Okay, the process to the negation though, let's look at the process. Okay, to take the process, using our different rules, okay, let me show you this with our rules. Okay, if we start out with our original statement here, we say, look, there exists an X where X is Democrat and X is not a politician. That's the same thing as saying not EX, right? And not there exists, which is really for every, yes? Okay. X is a Democrat and X is not a politician. But with this negate, we want to take the negation of the whole statement is our goal, right? So we're going to say, well, to take the negation of this statement, we have a negation here. Okay? Then we say, well, that's the same thing as saying a double negation of for every, and a negation here. And we have our different steps, which is, this is the vectors that you guys can translate to this. Okay? So the steps are great. Okay, those are in our notes. We're going to go over more of these steps today on how to identify them better. But if we're getting to this point right now, this is where we need to be. This is good. Yes?
So, do we need to show all that on our exam?
On a specific question, yes. We're going to go over that more today, though. Okay? Yeah, we're just trying to get the fact that can we get to here without? Can we understand how to get here, basically? Yes? These are all equivalent statements, right? These are all equivalent statements of the negation, but we want to get the most simplified form that's the bottom, right?
Why is there a negation outside the parentheses that just changes around?
These are just steps. Like I said, we're going to go over more step type questions like this today. So we're again, there's rules like rule of modus ponens, like we've been using those, right? So these are like the different rules that have been applied, and the different equivalent statements that we've used in past. So like
Yeah.
all those different theorems. Yes, yes, that proof idea.
I get it.
Okay, we're gonna do more examples with it though in a second. We're just trying to how to get from the first statement to the last. That's how. You guys are getting to the last statement just fine, which is good. Okay, 2b. Okay, here's some other ways to write 2b. For all x's, if x is a Democrat, then x is a politician. All Democrats are politicians. Okay, these are how you write the negation of this statement. Okay. Questions? Yes.
Do you have to write it out like that?
Yes, it says write it standard form. So it says write standard form, you gotta give me one of the red lines. You can either write this or this. There's actually 3 other options that aren't written here, too, but these are. This is the one I would go to. This is the one I would do. Because it makes most sense to me. Just easy for me. Because this is how you read this statement. Okay, this quantified statement. You read this statement like this.
Okay.
So if I can read this, that's what I'm writing.
I was just thinking for all X is a Democrat, then X is a politician, and then all Democrats. I thought it was just one big statement.
No, these are the same thing, these are equivalent statements. So this is one statement, one way to write it, this is another.
Got it.
So one way, another way. Okay? So yeah, both, either or, kind of on that. Okay, given the statement no fish walk on land, translate the negation in standard form. Some fish walk on land. Okay, that would be your answer there. No fish walk on land, okay, goes to some fish walk on land. Yes?
So that's actually true. There is a type of fish that can live outside of water.
Yeah, we're just looking on how to rewrite it right now. We're not looking at truth values, but that's good. Okay, notes. Example 32. Okay, if the statement is a compound statement and also contains quantifiers, then the rules from section 2 must be used with the rules above determine the negation. So, we have lots of rules in our notes. Okay? You need to be able to refer back to the rules and be able to think about, okay, how can I apply the rule? It's like, remember, if we go back to math that we're used to, okay, we think about 2 times x plus 2. What rule are you going to use to go 2x plus 4? What rule gets us from here to here?
You subtract your
Yeah, well, what rule gets us from this to this?
distribution.
Distributive property, right? So all we're doing with our quantified statements is we're looking, okay, if we go from one statement to the next, what rule gets us there? So you guys are learning a bunch of new rules for statements. And we're not doing actual calculations or algebra simplification here, right? We're trying to take a statement, rewrite it using rules.
I like a two-column group.
Huh?
I like a two-column group.
Yes, that's really what a proof is it just tells us how to get from one point to the next using some rules, right? So, we have to find the negation of the following. All dogs are beagles. And all cats are tigers. So this is a compound quantified statement. If we look, there's quantified statement number 1, quantified statement number 2. So we're putting 2 quantified statements together. Whereas before we were just working with 1 quantified statement. Now we have 2 quantified statements together. So if P is the statement, all dogs are beagles, and Q is the statement, all cats are tigers, De Morgan's law says, hey, the negation of P and Q, because look, this is P and Q, yes? You see that? Conjunction, yes?
Yes.
Okay? We need the negation of this conjunction. That means that's the negation of P and Q. And De Morgan's law says, hey, the negation of P and Q is just not P or not Q. Okay? We can use the chart above. Okay, if we go back to our previous notes, we can use chart above to say what's not P and what's not Q. So you got to be able to take this statement, rewrite it as not P, rewrite the statement as not Q. So you're taking a quantified statement, instead of just switching and putting not in front of them like we did at the beginning of the summer, now you've got to take the quantified statement and make it a negation. Each quantified statement. So P is a quantified statement. Q is a quantified statement. You've got to negate both statements to get the result. So, all dogs are beagles and all cats are tigers would turn into some dogs are not beagles or some cats are not tigers. And that uses, the reason this happens is because of this De Morgan's law. Okay, this De Morgan's law tells us how to rewrite the statement. Yes?
So you have to negate P and Q, and you have to negate the and. Does that make sense? Like kind of you negate the and to or.
Well, with De Morgan's law, yes, that's what happens. The and goes to an or. Yes.
Does that go the other way too? Like does an or go to an and or not? Like if you said all.
It depends on what we're negating and what we're changing. You have to go back and, again, we're going to use all of the rules. All, like De Morgan's law, we've got other theorems on our page. There's so many theorems, I'm going to give you guys the theorems on the test. Okay, you guys, you don't need to memorize what the theorems are. You just have to be able to say, okay, I can use this theorem here, this theorem here, this theorem here. Does that make sense? So yeah, you guys don't need to memorize this. You just need to know how to use it. You have to say, well, if I have P and Q, because that's what we start with, right? We need the negation of P and Q. And you would say, oh, well, that's really the same thing as saying the negation of P or the negation of Q. And you rewrite it as this. Okay, does that answer your question?
Yeah.
So, again, if I was in a college class doing this, most likely my professor wouldn't make me memorize all the theorems. I'm not going to make you guys do that either, right? So, theorems are tools. Okay, you want to have your tools by you ready to use. Okay, or your laws ready to use. Yes?
Do you guys make a sheet of theorems to use?
I'm going to give you the sheet.
Okay.
Yeah, I'm going to give you a sheet. Katarina?
Oh, that's what I was about to say. Is that I was like, do we really have to memorize all of the theorems?
No. No, we just have, you guys have to be able to use them. Don't memorize them. Okay? Sound fair?
If you want to.
If you want to, go for it. Example 33, we're going to do the same thing. We have a compound statement, compound quantified statement. Okay, number 33, we're going to walk through this and see if we can understand here. Okay, this is a little different. We start off with a disjunction. All dogs are beagles, or some frogs are not amphibians. So we gotta find the negation of this statement. So let P be the statement, all dogs are beagles. That's this guy. And then we have or, and Q be the statement, some frogs are not amphibians. So that's P or Q, yes? You guys good? Using De Morgan's law again, because there's different versions of De Morgan's law depending on what you're starting with, a conjunction or a disjunction. This time we're starting with a disjunction. We need the negation of this statement using De Morgan's law. And it says, hey, look, write that as not P and not Q. Okay? So your hardest part about this is going to be finding not P and not Q. Well, if this is all dogs are beagles, that's going to turn into some dogs are not beagles. So that's not P right here, not P. And then and is right here. All frogs are amphibians, because it says some frogs are not amphibians. Notice all switches to some switches to all. Not goes away. All frogs are amphibians. That's your statement. Yes?
If you're facing something with only one negation, does Morgan's law still work, or like the one without a negation, you put a negation, and then you take away the negation on the other one?
If you have a negation of a negation, it's just back to the original, right? So the negation of the negation of P is just P, yes?
Yeah. I was just asking if you had, let's say, not Q and P, could it be rewritten as Q and not P? I mean Q or not P?
Like that?
No, not like that. Could it just be, if not Q and not P, could you switch around and say Q or not P?
You mean just switch the letters around?
Yeah.
It depends what statement's at first. For this statement, our P was first and our Q was second. So it doesn't really matter where P or Q is at. It doesn't matter what letters we necessarily use. We're just saying if we are taking the negation of a disjunction, that's the negation of P as a conjunction with the negation of Q.
Okay,
Like
so
that rule, this rule always holds. This rule
Yes.
always is true.
I was just gonna describe a different scenario. If we just had one not. It was still just.
There's only one not there. One not. Is that what you're saying? No? Yes? We'll talk after. You can show me what you do, okay? Yes?
So the Morgan's law, is it just like rule that does my negation?
Our conjunctions and disjunctions. There's, again, several different laws, rules, theorems that we're going to be using. We're just using De Morgan's law here with our negation of our conjunction and our negation of our disjunction. Okay. Find the negation of the following. if some dogs are beagles, then all cats are kittens. So, P is our statement here, some dogs are beagles. Q is the statement, all cats are kittens. We need to find the negation of our conditional statement. So our conditional statement, if P, then Q. Okay? That rule is called denying the consequent. Okay, again, example 12, if you guys go back in your notes, example 12, that's where the Morgan Law is at, that's where denying the consequence is at, and several other rules. Okay? Denying the consequence says, look, we're going to deny, we want to take the negation of our conditional statement, which is the same thing as saying P and not Q. So we have P, which is good. And we're going to keep that some dogs are beagles. And then we're going to say and instead of then. And some cats are not kittens. And all cats are kittens here. We just say some cats are not kittens now. Questions on that? Let's look at stand up, take a break for a second. Stand up.
Yeah, I'm not good with that.
All right, Daisy. Okay, let's put a map up real quick. We need a map. Don't worry. Okay, let's back up. At the beginning of June, we talked about statements, yes? Right?
Yep.
Then we talked about negations.
Yep.
Then we talked about compound statements,
Yep.
which is our conjunctions and disjunctions, and our conditional statements.
Yep.
Okay? Then we talked about arguments, right?
Yep.
With those arguments, the arguments we had to prove valid using a truth table. And to prove an argument valid, what has to happen in the truth table with the last statement that we're trying to prove valid? Yes? You have to have a tautology. This is what our first part of June was, or all of June was like. What we're doing now is we're taking all of June and we're putting it into quantified statements. So we start off with quantified statements. We start off with negations. Then we said negations of quantified statements is what we talked about at the beginning of today, remember? Negations of quantified statements. Then we talked about compound quantified statements, just barely.
Yep.
Now we're going to look at quantified statements and arguments. Using those quantified statements in an argument and showing that the argument is valid. Using quantified statements. So it's really the same thing over again. Sometimes it's so much information, we fail to see the connection. So I hope you guys are seeing a connection with where we're going here. Okay. So, we have this argument. All cats have whiskers. Whiskers.
What's
Garfield is a cat, therefore Garfield has whiskers.
That's true. Garfield also has
We
a
also.
belly.
So, here's the thing. It appears the argument is valid, right? Even though it appears valid, is it valid?
It could not, it might not be.
It might not be. We have to show that it's valid. Okay? To prove it's valid, this is the rule we're going to use. Rule of instantiation or term substitution. Rule of instantiation or term substitution. Okay? Term substitution.
Garfield is a
So this is how we're going to show this argument is valid or invalid, is using one of these two rules. A rule of instantiation or term substitution. So, any statement, okay, preceded by a universal quantifier, what's our universal quantifier? Which one's our universal? Which one's our universal?
Upside down A's.
Upside down A, right? Okay? The variable indicated by the quantifier may be replaced throughout the statement by another term. In this case, we have substituted the term Garfield for the term cat. We can do this because of the universal quantifier all. Okay? So the above argument, let C be the predicate is a cat. So this is C. Okay? Go ahead and put the C above is a cat. And W be the predicate as whiskers. Okay?
Page 50. Disco girl.
Did we not use the rest before we do?
No.
That's what me and Allie are talking about.
Okay. The first premise, okay, our first premise, this is our premise, okay, remember, going back to our arguments that we did last week, you guys took a quiz on arguments. You guys remember that?
Yeah.
Okay? Premise, conclusion, yes?
Yeah.
So, our first premise is symbolized for every x. X is a cat if x has whiskers. All cats have whiskers. That's the premise. Okay, the second premise is symbolized by C. Garfield. Okay? C. Garfield. X, so Garfield is a cat. Garfield is the what?
Is the
Term. Garfield's the term. Okay, the conclusion is symbolized by Garfield has whiskers. So Garfield is our term. Okay, and that's stayed up here. Garfield for the term cat. So, if we take our premise 1 and premise 2, our argument can be written as such here. For every x, x is a cat. If x is a cat, then x has whiskers. Garfield is a cat. Then, therefore, Garfield has whiskers. Okay? So that's the symbolic form of our argument. You need to be able to do this. You gotta be able to do that symbolic form for the argument. So you gotta take that argument up there and go like this. Yes?
So, what exactly is the rule of
We'll get there. We'll get there. Okay. Here's the proof. This is the other thing you have to be able to do. It's much like our arguments that we've already done. So you're not relearning a bunch of new stuff. You're just putting complex ideas together. Okay, that's the hard part. So it's not a bunch of new stuff. It's just putting some complex ideas together. Or abstract ideas, I should say. So you got your two premises. Okay? Premise. If Garfield is a cat, then Garfield has whiskers. We can say that because instantiation or term substitution. Okay? We're substituting essentially here. Okay? We don't need the actual rule. When we say instantiation or term substitution, that allows us to switch the term Garfield into our, see how it's CX, if CX and WX? Do you see that? Eyes up. Okay? We've taken premise 1 and we said, look, we can substitute the term Garfield into premise 1, the conditional statement in premise 1, and put it here. That's the instantiation or term substitution. That's what instantiation or term substitution will do for us. Okay, that's the function of it. Now you're going to say, well, conjunction of 3 and 2, if I take the conjunction of 3 and 2, if Garfield is a cat, then Garfield has whiskers, and Garfield is a cat, that helps me say that Garfield has whiskers because of modus ponens on 4. The rule of modus ponens, again, I'm going to give you the rule so you can see it. If we go back and look at the rule, if we have a conditional statement as a conjunction with the first term in the conditional statement, rule of modus ponens says, look, if you have a conditional here, and it's conjunction with the first term, the first statement in the conditional, then you can conclude W, Garfield in this case, or Garfield has whiskers. Okay, so this whole rule right here is the rule of modus ponens being used. Go from 4 to 5. You have a conjunction as a conditional statement with another statement. That first statement here and the statements here, you can conclude Garfield has whiskers. That's what part of our conjunction is here. Yes?
So is the term substitution just, putting in the word instead of X,
Yes.
that's all?
Yes. That's the simple way to think about it for us. Yes.
So can you drop the E when you're doing this, or can you only like drop the A?
You mean the universal quantifier?
Yeah.
Good question. I would imagine, yeah, you can drop both. So, what I will give you guys, I'll give you the statements on the test. You give me the reasons. Okay, if this is what I've shown, if I can go from these two premises to this, is the argument valid or invalid? Valid, because we showed a way to get from here to here by using instantiation, a conjunction, and then rule of modus ponens. Okay? Instantiation or term substitution comes from the top of the page. If you look at the top of the page, okay, the rule of instantiation or term substitution, namely is, okay, this might come back to re-answer your question, Violet. Okay, when we look at instantiation or term substitution, all we're doing is when we have all, okay, when we have the universal quantifier, so who asked about dropping the percentage of your question to actually? When we have the universal quantifier, we can switch Garfield, the term Garfield, for the term cat, which all cats have whiskers. If X is a cat, so in this case, if X is a cat, right? X is our term. We can switch that X out for Garfield as a cat, or just Garfield. Okay? Because of the for all. So, no. Can't just drop it unless we have a rule. Instantiation and term substitution says, look, we can switch those out. Since Garfield is a cat and X is a cat, we can switch it out. Just think of it. X is a cat. Yes? Garfield is a cat. That's part of our premise. Right? So are X and Garfield the same thing?
Yeah.
Yes. To see that the argument holds and is valid, though, we've got to break it down and say premise 1, premise 2, does that really mean Garfield has whiskers? And we show that by rule of modus ponens. Okay? It all comes together. Once you substitute out X and Garfield, you can put it together using rule of modus ponens. Does that help looking at it that way?
Oh, but yeah.
Okay. Another argument, we're going to see if it's valid. Okay, one thing you guys missed on your quiz last week is you guys forgot to give me conclusions. I didn't mark down a ton of points, just marked down 1 point. So if you don't give me a conclusion, you didn't get the point. Good. And if it's not the right conclusion, then that would be another thing too. So, all camellias are white. The blue bonnet is not white, therefore the blue bonnet is not a camellia. I don't know if I said that right. Okay?
Chameleon?
Camellia. Sounds like a type of flower, I don't know. Does anyone know? What is it?
I think it's supposed to be camellia.
What?
I don't pronounce it camellia.
Camellia?
I think it's called.
Should we look it up?
It's butter. Blue bonnet is butter.
It's a plant. It's a plant.
Flower. Ooh, pretty.
Oh, that is pretty.
And pink. Do a thing how they say.
I love camellia.
Okay. Okay, all camellias are white. The blue bonnet is not white, therefore the blue bonnet is not a camellia. Let's see is a camellia. Okay, that's our first predicate. And W is white. The symbolic form of the argument is for every x, if x is a chameleon, then x is white. That's our first one, all chameleons are white. We're using a universal quantifier. So if we're using a universal quantifier, then we can say, well, here, the blue bonnet is not white, not blue bonnet white. Right? Okay, blue bonnet is not white. Yes, David?
I got a question and a statement.
Yes.
First, do you understand pigmented?
No.
I do. Well, it's 12:20, you should read
Is it already 12:20? That's nice.
that. Yeah, it is.
Hey, so what you're gonna do? I want you to try exercise 19. Okay, well, you should have enough information to do exercise 19. We'll talk about it tomorrow, and then we'll talk about our test. Hey, those of you that need to fix your corrections, get it done. Don't argue with Allie and Aaron about getting it done, too. You might as well do well since you're more than halfway done with prep. You might as well pass.